Introducing AIrTonomy, a new cyber-physical infrastructure that will allow the U.S. to lead the discovery of trustworthy artificial intelligence and machine learning systems for truly autonomous aerial vehicles flying safely in real urban airspaces. A key physical dimension of AIrTonomy is what we call the Purdue Unmanned Aerial Proving Ground, or PUP for short, with 4 testbeds geographically organized within a 15-mile-long corridor in the shape of a triangle. The Purdue U.S. Research and Test Facility, or PERT, the Smart Operations Center, what we call the SOC, both located at Purdue Airport. The Earhart Airfield, UAV airport for larger UAVs, located in the south, and the Purdue Urban Canyon Lab, or the PUC, in the north. While each physical component on its own offers unique capabilities for research, the major value comes from the integrative use of all 4. To ensure integration into real urban airspaces and allow vehicles to fly within PUP, we will work closely with our partner Saab Incorporated to install ground communication and networking infrastructure for urban airspace management. We call it the Purdue XDM system. We will now take a look at the AIrTonomy infrastructure at Purdue Airport. The PERT, established in 2019 at Purdue Airport, is the largest indoor motion capture facility in the world. PERT is 1/2 the size of a football field. Its motion capture system has millimeter accuracy and captures highly granular data about a vehicle's position in real time, using LED markers on the vehicles. PERT supports mixed reality testing and detailed sensor emulation. For example, the degradation of GPS can be emulated by computing line of sight to GPS satellites. The SOC, established in fall 2024, also located at the airport, is a highly reconfigurable space for research on immersive remote operations and other forms of human autonomy teaming. Equipped with a grid wall of screens, cameras for high-precision video and audio recording, virtual reality technologies, and wearable brain-computer interfaces, the SOC allows researchers to envision novel immersive interaction between humans and multiple or even hundreds of vehicles operating beyond visual line of sight. For example, in safety-critical situations, vibrations or brain stimulation may quickly bring a distracted human back into the loop to make accurate decisions in time. We are currently building the Earhart Airfield, a dedicated UAV airport, to allow researchers to study operations with larger UAVs. The Earhart Airfield will have a runway of 1,200 feet by 130 feet, hangarage for multiple UAVs, office and operations space, and will be a registered airfield with the FAA, displayed on air charts. Both the airfield and the vehicles operating out of Earhart Airfield will be equipped with a sensing infrastructure for ground truth data collection. At the Earhart Airfield, researchers can study the operations of 2 Purdue-owned mid-scale UAVs, Earhart and Armstrong, with a wingspan of 31 feet, maximum takeoff mass of 1,000+ pounds, and a range of 600+ miles. With a payload of up to 300 pounds, researchers can install and test various sensing payloads, such as hyperspectral cameras or synthetic aperture radar. At the airfield, researchers can study futuristic operations. Imagine Earhart flying from the airfield to the PUC, where they deploy a swarm of surveillance drones to detect fires in urban canyons surrounded by forests. The PUC is an outdoor urban canyon lab with temporary or minimally invasive buildings. In 2025, we plan to build it on a 12-acre field within the Purdue Martell Forest to study vehicle operation in urban rural areas and forests where signal degradation of GPS, radar, cameras, and other sensors prohibit nominal operation. Just like PERT, PUC will be equipped with motion capture technology. In PUC, researchers can perform flights at low altitude at extended and beyond visual line of sight, within or near buildings as well as around trees. The physical components of our infrastructure will be closely integrated with a cyber infrastructure to facilitate real-time access to ground truth data, high-fidelity digital twins, and tools for experimentation in the cloud using our physical facilities. We plan to build an extensible digital twin engine with baseline models for our vehicles, our facilities, human operators, and other physical systems. The goal is that researchers can run experiments remotely from anywhere in the U.S. The PEP is only the starting point of a large vision pursued by the AIrTonomy team led by Purdue's Center, AI for Digital, Autonomous, and Augmented Aviation, or AIDA. We envision PUP forming the anchor point of a UAV corridor of 200 miles, the Smart Crossways of America. This corridor will enable uncrewed aerial vehicles to safely transport cargo, medicine, and people from Purdue to Indiana sites in Crane, Muscatatuck, and Indianapolis. Join the AIrTonomy movement and the AIDA community to build AIrTonomy and the Smart Crossways of America, the nation's smart air corridor.